Hey, what is up, guys? It's your boy, Mike Shea. Today, I'm going to give you a short presentation on an attempt to predict the Dota 2 International 2025 tournament outcomes. My name is Mike Shea, and this is the data visualization final projects for the Johns Hopkins University Master's Program. So let's get right into it. Next slide. Okay, thank you. Alright, so here's what we're going to be discussing today. We're going to discuss the important terms to know what I'm talking about. Introduction to the problem, related works, my approach to the problem, and the results. And I'm going to give you a short demo if there's enough time. Alright, next slide. Alright, so some important terms for you to know. Dota 2. Dota 2 is a multiplayer online battle arena, or MOBA for short, where 2 teams of 5 compete. You can think of it as a multiplayer game, 2 teams, so 10 players in total, 5 players in each team, and the teams have to defend their base while attacking the enemy's base, and whoever's base is destroyed loses. Whoever destroys the other base while defending their own wins. And then there's the Dota 2 International 2025. So the International, or the TI, I think it's called the TI International, is a yearly tournament for the top professional teams in Dota 2, and I believe this will be the 14th TI for Dota 2, and the official start is September 11th. So, which is in the future, so around 3 weeks in the future. So we won't. I don't know the results of the tournament because it hasn't happened yet. So this is an attempt at predicting what would happen given the information that we have now. Another thing is that the Dota 2 TI is going to happen, I think, in Germany, Hamburg. So, and it's going to be around 16 professional teams. So 16 professional teams will take place in the Dota 2 International 2025. And it's there's 3 tournaments, or it's 2 stages, but it's like 3 tournaments that the teams will have to participate. First is like the Swiss stage. It's 5 rounds in the Swiss stage, and as soon as a team gets 4 wins, they automatically advance, which will be 3, automatically advance to the playoffs. The bottom 3 that have 4 losses drop out, are eliminated, and then the middle 5 go to the elimination round, and then the elimination round, if they win a match, they continue on. Then there's going to be 8 actual teams that will go into the playoffs in a double elimination bracket. So it's a bit complicated. I'll explain in more in details in the demo. But continuing on, then there's the drafting phase. The drafting phase is before every game. We have something called the drafting phase, and it happens before every start of the game. Teams pick and choose heroes to play as for the game. So they have to pick 5 heroes, 1 hero for each player, and if they pick that hero, the other team cannot pick that same hero. And usually teams pick heroes that they themselves are comfortable with, and that synergizes well with their team. And there's some strategy, a lot of strategy that goes on. Then the hero pool. The hero pool are heroes that a player or team have historically played. So if you play that hero and you do well with that hero, that hero is in your hero pool. So heroes that you play a lot and heroes that you have a high win rate with are in your hero pool. So it's like a set of heroes that you play with, and each team and player have sort of like a hero pool that they try and do well with, and usually they draft heroes that is in their hero pool. Next slide, please. Yeah. So the problem is that the Dota TI 2025 is in the future. Can we make a model to predict which team will win and provide some data visualization to help understand it? So we're trying to build a model to predict the future outcome of a future tournament with the given information that we already have, and visualize that outcome, visualize those outputs from the model. So previous work has been done for match results based off of the drafting phase. So we're not doing we're not predicting which team will win which match based off the drafting phase. What we're trying to do is predict which team will win the overall tournament based off of stuff we already know, such as the format of the tournament and um, the team's hero pool, the teams that will participate, the team's hero pool, and the structure of the tournament. Those are the things that we will take into consideration to predict who will win the overall tournament. The actual drafting phase is not will not be looked too much into, but it is important because if I go to the next slide, please. Thank you. So there has been some related work to Dota 2. So there has been actually many works on the hero selection analysis. For example, there has been a paper that multiple papers that have created a machine learning model to predict the match outcomes based off of the heroes picked during the drafting phase. So if someone if team A picks these 5 heroes and team B picks these 5 heroes, which team will most likely win just based off the heroes that were picked during the drafting phase. And then another paper that's a bit different tries and maximize the match win rate for a team by picking the best heroes. So which heroes to pick to maximize the win probability of a match. That has also been done. What this means is that it is possible to create a machine learning model to pick which team will win which match just from the heroes that were picked during the drafting phase. But teams usually draft heroes or in their hero pool. What I mean by that is teams usually don't pick heroes that they aren't comfortable with, because usually there is a learning curve to that hero and how it fits well with the rest of the team. And this is definitely true for players. Players that try and win usually don't pick heroes that they have no idea how they work, and so teams usually pick heroes that they have picked historically during the drafting phase. And if the drafting phase affects the match results and the hero pool affects the drafting phase, and that means the drafting phase can predict the match results. So that's what we're going to try and do. That's how we're going to solve this problem. So, sorry, next slide. Okay, sorry. Thanks. My approach. So, my approach involves collecting the data. How I collected the data was using the Open Dota 2 API. It uses Google Colab and API calls. So the Open Dota 2 API has like this documentation that shows all of the API endpoints that you can use. And then actually in one of those API endpoints, it actually allows you to run SQL statements, like SQL code. You can put SQL code directly inside your API call, and then the Open Dota 2 will run those SQL statements for you and then provide you the results in the JSON format. So that's pretty cool about Open Dota 2 API docs. Some data sets I got were like the top 5,000 professional teams. The team information of each of those teams. Some team information can be like I think players, like the player names, the the team win rate, the team uh, uh, hero win rates, the team's like basically hero pool, and then other things like the recent professional matches. I only looked at recent professional matches because Dota 2 has changed over the years, and so I'm only looking at recent professional matches. So it's around like 16,000 matches that I just want to look at a data set, which I think is enough. 16,000 for the machine learning model to look over. Okay, and then first, after I collected the data set, I cleaned it. I created a machine learning model from scikit-learn. Specifically the hist gradient boosting classifier. It got surprisingly decent. And it's basically trying to, the features that were chosen were the match result to the teams that participated, to the heroes, the hero pool of each team. Other ML models were tried. I tried XGBoost. It actually got very high accuracy. I think it got like a 90-something% accuracy, but it turned out to be like useless because I think it gave like weird results when I tried to run the Monte Carlo simulation. So I had to throw away because it basically just overfit and gave weird probabilities for certain teams. Next slide. Alright, so after the ML model was made, what I found out was running the ML model to predict which team will win based off the hero pools, it turned out to be computationally expensive. So what I did was turn it into a probability matrix. And then what I did was I dumbed down the model and distilled it. It's not really distilling, because distilling usually means like making one big model into a smaller model. What I basically did was take the model, memorize the answers, and then just creating a lookup table and just calling a probability matrix. And this works because what we're trying to do is predict which team will beat another team. And all we have to do is just memorize the answers. We know which teams will participate in the tournament. There are 16 teams that we know that are participating in the TI 2025 tournament. And so all we have to do is go through each team in the set of 16 teams. Go through each team, calculate run the model, the machine learning model, run it once, then run it again and again, 256 times to get the probability to get all the probabilities, 256 times to get all the probabilities that can be stored in memory without running a full model. So we basically have 256 memorized answers. And so if you want to see if team A beats team B, we just go into the lookup table and see team A, and then team B, and then output the probability. We don't actually have to run the machine learning model anymore because now we have the answers already memorized and we can just do a lookup. This increased the performance by over 20,000 times. That makes sense. And it's actually very important that we need to do this because it takes around 4 seconds to run the model in Python, Google Colab, and then in the Monte Carlo simulation, we would have to run like each match can have 3 games, and the Swiss tournament can have like 5 times 16 times 3, which is a lot, and then you have to run that like 1,000 times. And what ends up happening is that it takes like 30 minutes to an hour to run 1,000 or so Monte Carlo simulations. By making a probability matrix, it actually takes like less than 0.00001 seconds, or around that 0.0000 like 1 or 3 seconds, which is actually really good because it basically means that it runs the Monte Carlo simulations for 1,000 runs almost instantly. So this probability matrix is very important. Instead of running the machine learning model, the ML model for the Monte Carlo simulation, it has to be a probability matrix with the answers memorized. And then if we get a 16 by 16 lookup table, we can of course create a heat map of the probabilities. And so right here you see a heat map of the probability matrix. It's 16 by 16, 16 teams here, and then 16 teams here. And each cell contains, we'll go more in detail on the heat map later, but each cell basically just contains the probability of team A beating team B. So a team on this side, what's the probability of beating a team on this side? So what's the probability of Team Liquid beating Team like Paravision? And then that's the probability, and then the color shading, the darker the green is, the higher chance it is. The less shading of the green is less likely. And you can see strong teams based off of strong teams based off how dark a row is. If a row is very dark, it means that team has a high chance of beating another team. Is a very good team, has a high chance of winning. So you can see Team Falcons and Tundra Esports, they have very dark rows. Same thing with Team Liquid. These are going to be very, very strong teams. Team Liquid, Team Falcons, and Tundra Esports. You can see here, these are actually, this part is actually representing the team's hero pools, the shape of the team's hero pools. They are the win rates of each hero, the win rates of each hero for a particular team, in the shape of a radar chart / spider chart. We'll look into more detail on this in the demo, but that is what the heat map looks like right now. So creating and running the Monte Carlo simulation to requires learning how the tournament structure works. I'll go more into how the tournament structure works in the demo, because the demo actually kind of shows you the steps of the tournament that each team must go through by actually visualizing it. While explaining it now, it's kind of hard because it's like, oh, it's Swiss, but then there's elimination, then there's double elimination. How it's seeded is weird. But creating the Monte Carlo simulation, reading the structure and format of the rules that Valve has posted online, creating that Monte Carlo simulation in Python, Google Colab, and then running that tournament for 16 teams, and then running it over and over again to get a win probability. So this is like around 1, 2, 3, 4. This is around like 1,000 runs, or I think, no, 1, 2, 3, 4, 5, 6. This would be like, I think 100,000 runs. After 100,000 runs, these are the win probabilities. And you can see Team Falcons and Tundra Esports. Remember in the heat matrix, we saw these as strong teams, as well as Team Liquid. Team Liquid, Tundra Esports, and Team Falcons. These teams are like in the top 5. Yeah, top 5, and they have very high win probabilities. I'll go over why Team Nemesis is so far down here, and I'll explain it inside the demo. We'll look at the shape of the hero pool for Team Nemesis. So what I did for the final visualization is a web application in Vue.js to visualize the probability matrix in the Monte Carlo simulation. I converted the Monte Carlo simulation that was in Python, I converted it in JavaScript. And also the probability matrix. The probability matrix in Python was created using Seaborn, but I convert it to JavaScript using D3, the D3 library, the D3JS library. So it went from Google Colab and Python to JavaScript or TypeScript with the relevant TypeScript framework. There's a reason why I did that. I'll go into a demo why I did that. Because it's kind of hard to explain. I'll explain it a little bit, but basically, if I just use Python, Python web technologies is not very reactive. It's not very mature. Vue.js, React.js, AngularJS are very good for developing interactive web pages. So you kind of have to use JavaScript. So you kind of have to learn JavaScript to make something like this. Python is very good for Google Colab and Jupyter Notebooks. But Python's not very good for web development and interactive, reactive web applications. But it's very good for exploring and creating machine learning models and creating the probability matrix. So you have to both use Python to get the data sets, create the machine learning model, create the probability matrix, create a rough draft of like what the visualization might look like, and then converting that logic into TypeScript, into Vue.js, into a web application that I can then create an interactive visualization with. And then users can like run simulations. They can run the Monte Carlo simulation with different parameters. Users are able to use interactions such as mouse over and mouse hover to see more details on the team. I believe you can also do this in D3 charts. So I think you can also do this in some Python libraries, like Dart and stuff. But for mouse over and mouse hover, the awesome thing about using TypeScript is that it's actually kind of really easy to do that. As in it's a lot easier. I believe, to me personally, it's a lot easier to code that logic inside TypeScript and the Vue.js framework rather than in Python. And then of course the users can change the seating of teams. So the reason why we have interactive visualizations is so that users can explore what happens if they change some parameters. So I need to have the visualization, to have a lot of interactions, to have a lot of parameters that they can change so that I can see any effects on the outcome. Next slide, please. Alright, so the results. The results is that, from what I can tell, is that users can interact with the Monte Carlo simulation and see visualization of the tournament outcomes to gain an understanding of each team's strength, each team's like win probabilities, and users can also run a single tournament run and gain an understanding of the structure and format of the tournament, so they can better understand what is going on in the TI 2025 tournament, the structure, format, and like the flow of all the matches. And then the web application is also another thing about creating it in TypeScript or Vue.js. Another interesting thing in creating Vue.js is that Vue.js is device agnostic, as it can run the web browser. Python cannot actually run in the web browser. What Python is doing when you create a Python web application, it actually converts it into HTML and JavaScript. It creates a HTML template that sends to the web browser. The web browser isn't actually running Python. However, if you make it in JavaScript and TypeScript, it's actually going to run the JavaScript that is created by the TypeScript compiler. And Vue.js, what's awesome about Vue.js is that it's very easy to make it device agnostic, so that it can run both on the web browser of the desktop and also the web browser on the phone. So we'll see that in the demo as well. And you actually can see the web application here. So I'm just going to click on it. Let's start the demo. Alright. Can you see my screen? Alright, good. Okay, so this is the interactive web application. The first thing you'll see is like the nav bar, and than the actual content, the view of the page. And there's three things that we can look at: the probability heat map, the simulator, and the team stats. Let's just go over one by one. So the probability heat map is the view of the probability matrix that was created by the machine learning model from the data sets that we fed into it. So this is the probability matrix of the 16 teams from the machine learning model from the data sets of historical matches. This is the probability of Team A beating a team from Team B. Darker green means more likely for Team A to beat a team from Team B. Lighter colors is more likely or less likely from Team A beating Team B. So you can see just at a glance, the teams that are very strong are going to be teams that have dark rows. So Tundra Esports is very strong because this team has very dark rows. Same thing with Team Falcons. Same thing with Team Liquid. Another thing is that you'll see these radar charts or spider charts. The reason why I have these is because you can actually see the shape of the hero pool, the spokes or like the axes are the hero names or the specific heroes, and then the y-axis or the lines, how big the lines are, how long the lines are, or how far away it is actually the win rates of that hero. So spider charts with a large area means that there's a high win rate across all heroes. A spider chart where it's like skewed to one hero or skewed to one side is a spider chart showing that the team favors a certain play style. A spider chart that's like very spiky, that has a lot of spikes, are going to be charts that favor specific heroes. So we can just see down. So like this is a good example. This team is very spiky. So this here, the shape of this chart shows that this team favors very specific heroes. They have a very high win rate for very specific heroes. So it's very likely that they'll have a specific strategy in mind during the drafting phase. At least what I can tell. So Team Liquid has a very rounded shape of its hero pool, so it's going to be very it will have a lot of heroes that it's open to during the drafting phase, but it won't be very specific about a certain playstyle. That boom, kind of spiky, but overall, well, it actually is spiky. So, Team Tidebound, very spiky. Same thing, gaming. A little bit for gaming get light eaters. And Team Nemesis is the one that's interesting because it's like the most spiky, and there's a reason why. It's actually on the lower side of probabilities of being a certain team, but it has a very high win rate for the heroes that they play with, which is interesting. You'll notice that the spikes are like very long but very narrow, so it has very specific heroes that it's very good with, or it's going to pick, but it doesn't have a large, diverse hero pool. There's a few reasons why. It's probably because the data set is very small for Team Nemesis. Team Nemesis doesn't have a large frequency of different heroes. It doesn't have the data set that I collected doesn't have a very large, diverse sets of heroes for Team Nemesis. But Team Nemesis actually does in fact have a high win rate. Team Nemesis has like a 66% win rate across its professional career, and it has a very high win rate for the heroes that it has selected. So from the data, it seems that Team Nemesis is very picky about its heroes, but when it picks a good hero, it's probably going to win. So maybe Team Nemesis knows what it's doing. So that's the heat map of the team win probability. If we go to the simulator, we can see, actually before we go to simulator, we'll go to the team statistics. The team statistics is a page on the web application that allows you to see the team statistics of a team as if it was like a card, or as if it was like some sort of like Yu-Gi-Oh card, trading card, Magic the Gathering card, or like Pokemon card. You have like the team name here, which actually you can hover over and you'll get an exact copy of the card. I made it where if you hover over the team name, you get a view of the card. It's probably redundant information actually. You get the logo of the team name, the logo of the team, and the type of invitation that the team got. There are 16 teams. 8 teams are directly qualified with a direct invite. It means a direct invite means that the team is so good that they are directly invited by the tournament organization to participate. Regional qualifiers are strong teams in the region that have to win a regional tournament to get a regional qualifier invitation. Direct invites are a lot stronger because they were directly invited. Regional qualifiers are strong because, well, they're not as strong, but they got in because they had to prove themselves through a regional tournament. So you can see the spider charts. It's the shape is what's important. The spikiness is what's important, not exactly the names of the heroes, unless you want to look into that. And then the win rates of the heroes. You can see the team rating. The team rating is interesting because the team rating is the overall rating that is given by the tournament organizer in, Dota 2. It's the team rating that's given by Dota 2 in Open Dota API. I did not calculate this, but I just pulled it from the API call, and it's not used in the machine learning model. The reason why I don't use the team rating in the machine learning model is because what I'm trying to look for is using the hero pool to predict the win probabilities, not the rating to predict the win probabilities. The wins is the number of overall professional tournament wins. So overall in the team's career, how many wins have they gotten? How many losses have they received? And the win rate is between the wins and losses. These are from professional matches that this team has done, and the type of invitation that this team has done. And so it's like looking at a baseball card and judging if the baseball card is good or not based off of the statistics and the shape of the card. That's the idea that I was going for. I think it's okay. Then we have fuzzy search. So these are sorting and filters. So you can sort by team name, team rating, and other stuff. You can see only direct invites. So you can see these are all direct invites. I can reset and hide it. I can try and see teams with very high win rates. Let's look at win rates, and I can sort it from this descending. So this is ascending, descending from highest to lowest. We can see that Paravision actually has a very high rating, has the highest rating across all teams. Then Team Nemesis. This is again, I'm gonna put a pin in Team Nemesis because Team Nemesis has a very high rating. Sorry, I was looking at the wrong one. I was like, okay. Very high rating. But you'll notice throughout the Monte Carlo simulation is actually going to lose a lot of games. Okay, so that's the wait, hold on. No, okay, this is the rating. Was I? Sorry, I'm just getting confused. I think I put in the wrong parameters in. Paravision. Okay. Team Nemesis does not have a high rating. I just put in the wrong. I put in too many filters and confused myself. Team Nemesis has a very low rating. Yeah, it's actually towards the bottom. Sorry, Team Nemesis has a very low rating, but it's a very high win rate. If you sort by win rate, there we go. Team Nemesis has a very high win rate, but a very low rating. This is because Team Nemesis is actually a very new team. It's a very new team, and they don't have a lot of history of that many matches of very good teams, because the rating's determined by how many good teams you've won, and the win rate is just how many matches you've been in and how many matches you've won. So that's the team statistics. Another thing about this is that I use something called global states. So Vue.js using Pinia, the Pinia library, it has something called global states. So if I go to probability heat max and go back to team stats, you'll see that my filters are saved. So if I click here, my filters are actually saved until I reset them. Another thing about team statistics is that because it's Vue.js, I can actually see the mobile view, and it's actually decent. There's fuzzy search, so if I type in, yeah, RE, the fuzzy search is as long as that string is within the substring, as long as the substring is within the string of our team name, you'll get that. And it has a decent mobile view, so nice. Let's go into the simulator. The simulator has two parts. It has the simulation runs and the run single tournament. And I can actually discuss how the tournament setup is going to be. So if I hit run single tournament on random adjacent, you'll see the visualization of the tournament. It first starts in the Swiss stage. And in the Swiss stage, it goes from round 1 all the way to round 5. Round 1 all the way to round 5. In the Swiss stage tournament, how it's happening is that all teams start in round 1, all 16 teams. And if there's 16 teams and the match requires 2 teams, then there's going to be 8 matches. 1, 2, 3, 4, 5, 6, 7, 8. 8 matches. Each match, the team plays 3 games, or up to 3 games. And if they hit 2 games, they advance, they win that match, and they advance into the winning bucket. So this bucket is for everyone, 16 teams, and if a team wins, like Nautis Vincier, if I hover over this name, of course I see the card, like the trading card, and I can see the stats. So Nautis Vincier has these stats. It's a regional qualifier against another regional qualifier, 53.94 versus 54.28. But they're actually very similar. So they actually got like very similar results, with Nautis winning the last 3rd game. So Nautis Vincier won. So if I scroll down, I'll see Nautis Vincier against a different team. Extreme Gaming lost. So it's going to go into the losing bucket. This is the number of wins, and number of losses. So Extreme Gaming goes into the losing bucket because it lost, and goes against another loser, which is Wildcard. Wildcard can be found around here. Wildcard lost, it goes to the losing bucket. This is the winning bucket, so Nautis Vincier versus Tundra Esports. Tundra Esports is in this bucket, so they won the last game. So Tundra Esports is right here, and you can see that they won. and then continues on to round 3 and round 4. The thing about round 4 is that it's a bit special. If a team gets 4 wins in a row, they actually do not need. If they get 4 wins with 0 losses, they actually do not need to play again inside round 5 because they get automatic advancement to the playoffs. So Team Spirit won, got 4th win, so they actually won't appear in round 5, which is right here. I do not see a team. He's Team Spirit. If a team has 4 losses with 0 wins, so Extreme Gaming has 3 losses right here. They lost again, and so they will go. They're eliminated, and they actually do not advance to round 5 because they just won't be able to go in. So Extreme Gaming lost round 5, so you actually won't see Extreme Gaming inside round 5. They lost round 4 with 4 losses, so you won't see Extreme Gaming in round 5. Basically, seeing this single tournament run allows the users to have a better understanding of how the tournament is structured and formatted. Another thing is that the random adjacent is actually how is actually saying for the Swiss stage how the teams are going to be matched up. The 1v16 is actually how a normal Swiss is conducted. However, Valve in their newsletter said it'll be random adjacent for Swiss. While 1v16 is usually for other tournament runs in Swiss. There's actually a real interesting reason why adjacent and 1v16 are chosen for Swiss or other tournaments. There actually has been cases where due to poorly formatted tournament organization, when the tournament was poorly organized, there might be cases where a team has a higher chance of winning the overall tournament by losing specific matches. As in the poorly organized tournament, a team might lose on purpose so that they have a higher chance of winning the overall tournament, which is really bad because you could have a case where both teams are trying to lose to increase their chances of winning the overall tournament. Valve went with adjacent. Usually Swiss is match 1v16, match seed 1 versus seed 16. And the reason why is because if you do it like that, is you reward teams for winning in the seed 1 versus seed 16. Seed 1 versus seed 16 means the best teams are always facing off the worst teams, whereas adjacent means the best teams are always facing off the best teams, the worst teams are facing off the worst teams. Valve decided to go with adjacent so that each match would always be interesting to watch. It won't always be a stomp, so you'll always see the best teams versus another best team in the Swiss. Other brackets are going to be 1v16. Other brackets like the elimination and the playoffs are going to be best teams versus worst teams, but according to Valve, it's going to be adjacent for Swiss. And these are the final standings for the Swiss. So you can see the top 3 are going to be teams with 4 wins. The top 3 teams with 4 wins will automatically advance to the playoffs. The middle 5 will have to go to the elimination round, and the bottom 3 are eliminated. Teams with 4 losses are eliminated. So you can see the placements, the advancements after the Swiss stage. These have to go to the elimination round. These are outright eliminated. These advance to the playoffs. This is the elimination round. The elimination round is the second stage after the Swiss. it is each team, the strongest team is matched up with the weakest team from the Swiss, and they play 3 matches. The losers are eliminated. The winners advance. And then, so you can see wildcard advance, Bet Boom versus wildcard, Paravision versus Heroic, direct invite Paravision versus Heroic, with Heroic winning. Interesting. And then this is the double elimination playoffs. How double elimination works is that a team has to lose 2 matches to be eliminated. All teams start in the upper bracket. If a team loses, they go into the lower bracket. If they lose again in the lower bracket, they are eliminated. Meaning that teams have essentially like 2 lives. They have 2 chances of reaching the grand final, and they are allowed to lose 2 times. And it's also, the seeding works like this. The seeding is from strongest to lowest, according to Valve's official statement. Strongest team versus the weakest team. And there's a reason why for that. You want to reward strong teams, so you want to give them incentive for the strong teams to do well. So you make them match up the weakest team, so that teams don't throw on purpose to avoid fighting other strong teams. And another thing is that they don't want the strong teams to attrition each other, and you want all strong teams to make it to the grand final to have a very awesome match. So that's like the structure and format. You can see here, Wildcard somehow wins against Team Spirit. That's interesting. Team Spirit loses. So Team Spirit is in the upper bracket. Because he's in the upper bracket, Team Spirit just goes down into the lower bracket and continue on playing. Boom Esports already lost from the upper bracket. So Boom Esports is in lower bracket. Boom Esports loses again. Sorry, Team Spirit loses again. Boom Esports won. Team Spirit loses. Ends eliminated. So you won't see Team Spirit in the next round. Boom Esports wins. Boom Esports goes here. Boom Esports wins. Wow, Boom Esports just keeps on winning. What? And it's Boom Esports that wins the grand final. Boom Esports is actually not supposed to be winning. I'm not sure what happened. And then, of course, you can change the seed to run a different tournament. This time it's Team Falcons. I'm actually surprised that Boom Esports won because they have a very low probability of winning. It's usually going to be Team Falcon that wins. Heroic has a very low chance. Tundra Esports has a very high chance, so I expect Tundra Esports to win a lot. Okay. And then we can run a simulation of let's do 10,000. We can run many simulations, we can see what happens here. Another thing about this simulator is that it uses global states. So if it's in if it is in a loading screen, if I go out and I come back in, it's still loading actually, because states is stored, which allows me to go into different pages of the website without destroying state, which is, I think, is very interesting. Another thing that I kind of want to show is that the application does work on mobile. It's just a bit finicky because I still need to work on that, but it does in fact work on mobile. Just a bit finicky for single tournament runs. For the simulation, it works a bit better. slightly better. And then we can just look at the simulation runs for 10,000. Let's see. So we expected this. Team Falcons are very good from the probability matrix. Same thing with Tundra Esports and Team Liquid. These are like the top three. Very likely for these teams to win, and Team Spirit. Very likely for these teams to win. Very unlikely for, according to the probability matrix, Team Nemesis, Wildcard, and Heroic. Even though Team Nemesis, you can hover here, has a high win rate and a decent rating, it's very likely that Team Nemesis, like hero pool, even though they have a high win rate overall, because of the shape of their hero pool, the probability model does not like it. And so, because they don't have a large hero pool, the probability model thinks that Team Nemesis is going to get like outdrafted, essentially, by like Team Falcon, which has a larger hero pool, Tundra Esports, which has a larger hero pool, and Team Liquid, which has a larger hero pool. So it just does not like Team Nemesis. You can see the Swiss stage. These are the reach probabilities of every final record buckets. So these are the reach probability of the final record buckets. What's the probability of Team Falcons to receive a 4 wins, 1 loss? Team Falcons has a high chance of getting into a 4-1 bucket. What's the probability of Team Falcons getting 4 wins, 0 losses in the Swiss stage? Also pretty high. What's the probability of Team Falcons getting a 0 win, 4 losses? Is actually very low. Very low. And what's the probability of Team Falcons getting 1 win, 4 losses? Is actually very low. So these are the reach probabilities of the various teams. Obviously, if you want to get past the Swiss stage, you want to do well in the final records in the 4-1s, the 4-0s, the 2-3s, and the 3-2s. Teams that have a high chance of being eliminated in the Swiss stage are going to be in the final records 1-4 and the 0-4, because if you get 4 losses, then you're automatically eliminated. So the teams that have a high chance of getting automatically eliminated are Team Nemesis, Wildcard, Aurora Gaming, and Heroic. Paravision. Okay. And then the elimination, the next step after the Swiss stage is the elimination round. And we have the probability of the first one is the probability of a team that are forced to participate in the elimination round. It's the probability of a team being forced to participate in the elimination round. Teams that are forced to participate. So imagine being in these buckets: 2-3 bucket, 3-2 bucket, are the buckets in the Swiss stage where you are forced to participate in the elimination round. And then the advances to place are, so if you get into the participation round, what is the chance that you will go to the playoffs? What's the chance of winning the elimination round given that you're in the elimination round? It's actually the very strong teams that I've been saying over and over again. Team Liquid, Team Spirit, and Tundra Esports. Very high chance of advancing out of the elimination round. And then, of course, very unlikely for Team Falcons, Team Nemesis, and Team Falcons, Tundra Esports, and Team Liquid. Well, actually, these are actually high chance that they'll actually participate. These are because it's actually over 50, so there's a good chance that Team Falcons does participate. Actually, okay. According to the model, okay. That's weird. Playoff stage reach probabilities. Okay, so this is the probability of a team of visiting a specific bracket. What is the probability that a team will end up in the upper bracket quarterfinals? So if they actually made it to the quarterfinals, they'll start in the upper bracket quarterfinals. What is the chance that they make it to the semifinals? So this means that they didn't lose in the playoffs. What's the probability that they make it to the final? What's the probability that they make it to the uh well, this would be if they lost in the upper bracket in the quarterfinals, and what's the probability that they reach the grand final? So very low for certain teams, but very high for the stronger teams. Okay. So that is the tournament simulator. It's going to be very good for visualizing the structure and format of the tournament and visualizing the strength of each team, and also providing information, a very overall visualization of their hero, the shape of their hero pool for that specific team, their hero pool, the diversity of the heroes, and the hero win rate, and then overall team information, and like that's like uh, what it's trying to show. So hopefully you guys like that. All right, I'll see you guys later. Bye.